Hi guys, it's Penguin Design bringing you the fourth part, I believe, maybe even the fifth part of the Crossy Road tutorial series. So in this tutorial we're going to be doing something really important. Now it may not be that exciting, but what it is fixing core mechanics. What that means is the core features of the Crossy Roads game would be the ability to jump and the level generation and the camera following. So we've done all those right, but due to some comments I got, there is a bug with the bounce and animation controller script, and it's pretty much a game killing one. So what I'm going to do is open up Unity and open up our previous Crossy Road project. So here's the bug. It works fine like this, but there's a few things I noticed as well apart from the bug. One, the rotation is not rotating around the center point, which although it's not that important, it still makes a difference. And the next thing is if you press the forward arrow really quickly, what will happen is he will sometimes bounce up in the same spot. And the way I've decided to fix it, I spent a while trying to figure out how to do it. See, as you can see here, it's just that's unplayable, because even though it may not seem that important because the person has to tap the key really fast, most of the time when they're playing Crossy Roads they will be trying to tap the key as fast as possible. So how are we going to fix this? We're going to go into animation, and I'm going to warn you, this is going to be a long one. Select all of them and hit delete. Okay, yeah. I've decided that all this animator stuff is probably not the best way of doing it, because if you remember in my code I had if the timer was above 0.8 and all that garbage, it doesn't really work that well. So we are going to have to use one animation, but that's pretty much it. Also what we're going to do, obviously remove the animator component from the chicken object, but we're also going to remove the animation controller script and add it here. Animation controller. Now, even though it's called animation controller, what it's going to actually handle is the rotation of the player. So first we're going to fix that by, if we click on our player object and press F in the scene view, and we click here to get a top-down view of it. I'm just going to turn off gizmos for a sec. What we want to do is, if you see this parent object, if you click on, usually it will be looking like this, and rotating around that's fine. But if you click here on the center button, pivot, this is where the computer rotates. As you can see, this isn't a central point, and so it doesn't rotate that well. So how do we fix this? But just get this chicken object and drag it over until this looks like it's about in the center. So maybe a bit like this, a little bit more. Okay, so now it should be rotating a bit more around a central point, and yeah, that's working very nicely. I prefer to have these neater numbers, so I'm going to go 0.3 and negative 0.3. So now parent object, yep, that's rotating around a center point. And also under the chicken object, I'm going to set its y-axis to be 0.6 and just set its rotation to be 0 again. So now this should all be good. What we're going to do is, now in the animation window, we are going to be doing one animation, but we're not going to be doing a whole lot of animation controller stuff. So here we're just going to hit record and call this jump. And in this jump animation, all we're going to do is animate its position. So all you have to do to get the first keyframe is, I don't like hitting add property, so I'll change this to 0.4 and then change it back to 0.3. Now if I go to 0.05, I'll just set its y-axis to 1.6 and then go to 10 and I'll set it back to 0.6. Okay, so now I got a nice quick jump animation. And so now we'll hit the record button again and get rid of this animation controller, go into our project window, delete the animation controller. And now here's something a bit fancy that you probably didn't know about this, is that if you want to control animations without an animation controller in code, you have to do something called marking them as legacy. Now they've removed this option, so what you have to do is here, 3 bars in the line, click on debug. Now this is, you'll rarely have to use this, except right here, you can tick legacy and then go back to normal. So now in our chicken object, if we go add component, miscellaneous animation, we drag in our animation clip, that would all be working, and it will work in our code too. So now we've got some changes to make to our parent object, and that is that our bounce script is going to be really much better than before. So first though, we're going to have to change the animation controller script. So I'm going to go into scripts and double click on animation controller, and I'm basically just going to delete a whole lot of stuff. So delete all of this up to the void update, we don't need any of it. And we can get rid of this whole if the just bounce and set bool, okay? And we should be just left with the rotation code. So that's good. All we have to do is hit Control S and go back into Unity. Okay, so now we're going to work on our bounce script. So this is not going to be as easy. We're going to have a ton of variables, so let's start writing them. So we're going to first create a public float lerp speed. So we're going to write public float lerp speed, and I like to set it to be 5. And now we're going to have a public float scale speed. So what this is the amount of time it takes for the object to scale down, and that's because in the original Crossy Roads game I was playing it and I noticed that as you press your thumb down, your character scales down a bit, and then when you release, he jumps. So we have to implement that. And now we're going to create a public transform, and this will be the child object. So that's just self-explanatory. We'll get rid of these variables just because it might be a bit tricky for me to remember them all. Now we'll create a public float again, and this will be the amount of change it has on the axes for the scaling. So for example, I'll call it scale change first and then I'll explain it. So scale change, and what this is is that when you're pressing down the arrow, it will lerp from on the y-axis, on the z-axis being 0.9 I think, and the x-axis being 1.1. Not really sure about that, but it's one of those two. It's just the amount of difference in scale for the player. So now this is a new one that you guys probably haven't used, and I've rarely used too. It's going to be an animation curve. So I originally did this using trigonometry, and then I was looking on the forums and I found out that there's an easier way, and that's using an animation curve. I'm going to call it AC. And so what an animation curve is it's just a curve. And so we're going to make this affect all our lerps so that it starts out slow, gets quick, and then gets slow again. This is really important though for the scale change, more than the position change, but that will just make the game a whole lot smoother and it won't add that much code. Public animation, so this is the miscellaneous thing that we added with our animation in it called anim. Okay, and now we're done with publics. We're going to create a float, and this will be current lerp time. We've already got that, and we can actually delete lerp time. I'm not really sure why I put it in there because I don't think it has a purpose. So we have this current lerp time variable, and that's changing its position. So we're going to create another one, and this will be called current scale time. So this is just like the other variable except for changing scale. So float purse equal to 1, that's good. And then we'll have float scale purse, and we won't set it to be equal to 1 to begin with. Okay, now we need our vector 3 start pos and end pos. We'll copy these and rename these to not start pos but start scale and end scale. So this is to do with the changing the scale of the object. And we don't need these two booleans. Actually, you know what? We're going to have one more bool, and I'll call this first input. Okay, so first imp. By default, if you don't say equals to anything, it's false, and that's on purpose. So before we fix up all this, because we deleted variables, first going to do stuff in the void start. So this is called the frame that the game starts. So what I'm going to do here is take the opportunity to set our anim and child variable. So I'm going to use anim equals game object dot transform dot find child, and so this is because in our Unity, where our child object we want to be the chicken. So, and because the script is applied to the parent object, we're finding the child named chicken. Okay. So game object dot transform dot find child. Open up parentheses and some quotation marks and chicken. It is case sensitive, so you have to do it right. So chicken with the right capitalization too. Dot get component, and we want to get the animation component that we had. Okay, so add in two parentheses because it is a function, and add in a semicolon. Now we're going to set our child variable, and it's going to be a pretty similar situation. So what we can do is copy this line, and I'm pretty sure that is not how you spell anim. Anim, and okay. So I just had a silly brain fail. But over here we're going to set child equal to gameObject.transform.find child. We don't need this get component animator stuff. Add in a semicolon, and that's all for the void start. So now we can move on to the task of void update. Okay. So first, so here where we have if input.get button down, I'm just going to just get rid of everything in here and change it to be current scale time to be equal to 0 in this block. Okay, and now you're thinking, wow, you just removed everything of importance. Well, we're going to add it in too. So get rid of this start pos equals to, copy this block and paste it right here, but here's the difference. Instead of get button down, we're going to have get button. So the difference between get button down is and get button down is called the frame that the person presses the key, whereas get button is called every frame that they're pressing the key. So this is pretty important what we're doing in the get button, and that is we're setting start scale to be equal to gameObject.transform.local scale, and we'll set end scale. Now this is a bit different, equal to a new position in 3D space, so that's vector 3, and we're going to set it to be transform.localScale.x plus the scale change variable. Scale change, I'm pretty sure it was called. Oh, I spelled scale change wrong up here. So now set it to be equal to plus scale change. There we go. And make a comma and then go transform dot local scale dot y minus the scale change variable, and we can just go transform.localScale.z. Okay, so now we're going to do a little bit more in this input.get button, and that will be, we're going to set the first input to be true. You could actually do it in the get down, but it doesn't really matter. It functions the same. Okay, so now we're still not done. We're going to have input.get button up. So get button up is where all the movement and stuff is going to happen. The reason we had get button is because when they're holding down the button, we want scale to change. So now we can go here. Well, actually, you know what? We'll copy this line of code, this box of code, and get rid of all the stuff inside it, and rename this to get button up. Get button up. So as you can imagine, get button up is called when the person releases the key. I mean the player, sorry. So get button up finally. So now this is where a large portion of our code is going to be. So first, to make sure that they haven't started jumping before they've finished their previous jump, we're going to check if the percent variable is greater than or equal to 1. Then they can execute this, so that's just to make sure. And so now we're going to do a few things. So we're going to write anim.play, and we're going to play our jump animation. Okay, now we're going to set current lerp time to be equal to 0, set current scale time to be equal to 0, set pers equal to 0, set start pos to be equal to GameObject.transform.position. Oops, looks like I should be using a dot, not a comma. And we're going to set start scale to be equal to GameObject.transform.localScale. And we're going to set end scale to be equal to a new vector 3, and this will just be 1, 1, 1. So I'm going to explain this. So all of that is, apart from the anim.play, is just setting the variables back to 0. But here we're setting the start pos to be equal to the current position of the object. But the reason that I've done this is because right now, when they're releasing the button, the object scale won't be 1, it will be like 0.9 on the X or so. So we just want it to lerp back to 1 when the person's jumping. Okay. So now we can move on to this block, the if get button down. So what we're going to do is rename all of these to get button up. So it's a bit annoying, but you know, I have to do it. So I don't know about this. We're doing a lot of code here, so I'm a bit worried about getting some errors after this, but hopefully it should work fine. I'm a bit worried about it though. So all of that end pos is equal to a new vector 3. That is all fine. We don't have to touch this block, thank God. Now we're going to be doing the rest of our work here. So this is all the code that handles the lerping. So we're going to rename this to first imp. If first imp is equal to true, and in actual fact in Unity, and for that matter most other coding languages, if you don't write equals to true, you just write if first imp, it will automatically check if it is true. So that's pretty useful. So here we've got current lerp time plus equals time.delta time. I'm not going to write times 5, we're going to go times lerp speed. Okay, that's just a bit neater, so we can change it in Unity. Now we're going to set pers to be equal to current lerp time. And what we're going to do here is where it says GameObject.transform.position, all of that is good except here. Where it's changing the pers variable, we're going to get our animation curve, I think it was. So we're going to use ac.evaluate, then the pers variable. So this will just make it, because the percentage variable will be going from 0 to 1, that'll just make it go a little bit quicker when it's nearing, when it's halfway. So I was originally doing with this trig, like I told you, but this is a much neater way of doing it and less complex for that matter. So now we've actually just done, as you saw, I just deleted a bit, but that's all our changing position code, I believe. And now we're going to do our changing scale code. So we're going to say current scale time plus equals time.delta time. Multiply this by scale speed. Okay, I don't know why it's not showing up, but hopefully that should work though. Now add a semicolon and we'll write scale percentage is equal to current scale time, semicolon, and we're just going to be doing a similar line as code as that, except instead of doing game object, we're going to go child.transform.local scale, and we're going to set this equal to vector3.lerp linear interpolation, and we're going to set it to lerp from start scale to end scale. And we want it to do that by the scale pers variable, but as you remember, we can do it without trigonometry. We can go ac.evaluate and scale pers. So give that a save, and MonoDevelop is giving me a few red lines, but those hopefully won't create bugs, and if they do, Unity will give us a heads up on what that is. So hit File, Save, or Control S for that matter, and go into Unity, and it looks like obviously we are going to have some errors. Unexpected symbol 3 in class struct. It looks like I forgot to add in an equal sign, a little bit silly. Save that, close it up. Looks like we have no errors, but just in case Unity crashes, hit Control S. And in our parent object, we're going to have to set these variables. So don't worry about dragging in the anim or child, because if you remember, in our start function, we set those variables. But we are going to set our AC curve. So I like to just have it like this, but if you want, you could make it more intense or less intense for that matter, but I'm fine with the default. So just make sure it's curving like this, not this. Okay, and so now we're going to set, actually all of that looks good. Apart from the AC, that's all we had to set. So hit Control S once more, hit play, let's hope this works. Okay, so that is working. I saw that the first instance didn't work, but that's about the only issue we're having. So as you notice, if we press the up arrow, it scales down, and when you release, it jumps. And even if we tap it really fast like we were doing before, it doesn't have that really odd issue of bouncing up 3 or 4 times. So that is actually a much better system than before, and that's because we're doing the lerping in code. We don't have to mess with the messy animation controllers, and even though the script is called animation controller, it's just handling rotation, and it actually functions a bit more like the original with the scale changing and the changing direction. It's changing direction around the central point, and so that is all looking really good. So see you next time, and I hope you enjoyed this tutorial.